Good morning, champs. Today we solve our first real section force problem. The goal is to find the internal axial force, shear force, and bending moment inside the beam. We will use the notation N of x, V of x, and M of x. The beam has a pin support at A and a roller support at B. The total length is 4.8 meters. At a distance of 3.2 meters from A, a vertical force of 200 Newton acts downward and a horizontal force of 200 Newton acts to the left. We start with the support reactions. In the horizontal direction, the support reaction AX must balance the horizontal force. Since the external horizontal force acts to the left, AX equals 200 Newton to the right. Next, we calculate the vertical reactions. Taking moments about A gives so By equals 133.3 Newton. Using vertical equilibrium gives Ay equals 66.7 Newton. Now we want to know what happens inside the beam. Since the load is located at 3.2 meters from A, the beam has two regions. Region 1 is left of the load. Region 2 is right of the load. We need two regions because the free body diagram changes once the cut passes the force. For our sign convention, on the left cut face, positive axial force points to the right, positive shear force points downward, and positive bending moment is counterclockwise. If a result becomes negative, that simply means the real direction is opposite to the direction we assumed. First, we cut in region 1 before the load. The left free body contains the reactions AX and AY, and the internal forces N, V, and M. Horizontal equilibrium gives AX plus N equals 0. Since AX is 200 Newton, N equals negative 200 Newton. This means the axial force is opposite to the assumed direction. Vertical equilibrium gives AY minus V equals 0, so V equals 66.7 Newton. Moment equilibrium about the cut gives M minus AY times X equals 0. Therefore, M equals 66.7 times X. Now we cut in region 2 after the load. The left free body now includes the support reactions and also both applied forces. Horizontal equilibrium gives AX minus 200 plus N equals 0. Since AX is also 200 Newton, the axial force becomes 0. This makes sense because the horizontal load cancels the horizontal support reaction. Vertical equilibrium gives AY minus 200 minus V equals 0. Substituting AY equals 66.7 gives V equals negative 133.3 Newton. For the bending moment in region 2, we again take moments about the cut. The equation is M minus AY times X plus 200 times X minus 3.2 equals 0. Solving gives M equals 66.7 X minus 200 times X minus 3.2. Simplified, this becomes M equals negative 133.3 X plus 640. Now we have the complete internal force functions. In region 1, N equals negative 200 Newton, V equals 66.7 Newton, and M equals 66.7 X. In region 2, N equals 0, V equals negative 133.3 Newton, and M equals negative 133.3 X plus 640. Let's check the bending moment. At A, where X equals 0, the moment is 0. At the load position, X equals 3.2 meters, the moment is 213.3 Newton meters. At B, where X equals 4.8 meters, the moment returns to 0. That makes sense for a simply supported beam. The most important lesson is the workflow. Solve the support reactions, split the beam into regions, cut inside each region, add N, V, and M, and apply equilibrium. The horizontal force changes the axial force, the vertical force changes the shear force, and the bending moment changes its slope at the load.